at the moment, we also have this estimation that the contribution to the worldwide GDP growth is 2% from AI practices. So this one is definitely it will definitely increase, that's for sure. So just a little bit, first the agenda. We're going to try to cover mainly all the angles of a product manager. So this is not about really the technique that data scientists use, although we'll touch on some points today, but it's more about, as product manager, what's the difference and what do we have to do extra. So we go through the use case, the typical model we can use, this new team you're going to work with, data scientists, and some important consideration of the user experience, the metrics for your product, and maybe some new collaboration and partnership ecosystems. So yeah, my career has been pretty much the whole way on product management. Always B2B SaaS is my specialty, but very different proposition. IBM was enterprise analytics, Tesla unified communication. For the last 3 years, I was focused on cybersecurity. First wave was email and web protection. This cybersecurity is a great domain for machine learning because there's a lot of data and a lot of consistent format. So, you know, when you click on a website on one link, there's about 50 logs entry. So between the device, your router, the telco router, the firewall, then the server environment has another firewall. There is some detection system, and then the HTTP server, and then the applications behind it, the database. So one click generates about 50 to 100 log entries. So it's great data for machine learning. And so I launched Cyber Assist through the Entler Accelerator program. I recommend that. Actually, that's the way I met you, David. That's at Entler.
Yeah, that's right. Back in the days. Mm-hmm. Yes.
And so Entler is great because you work with a lot of different people, and then you focus on one proposition. And my proposition was Cyber Assist, which was a virtual assistant for cyber professionals. So the idea is to accelerate the treatment of incidents. You know, when you work on those screens of alerts, it's very tiring. So we wanted to make it simple, just highlight an indicator of compromise or highlight anything and right click, ask Cyber Assist. I mean, the idea is to provide the best next step recommendation. And to do that, just to high level, we did explore, and thanks to my co-founder, was an Azure guru, Azure AI, so more Microsoft side, but it's the same technology. So we use 3 components to help the analyst. First is the history of all the cases that happened before, trying to find a similar case. Threat intelligence platform, it's about retrieving the right intelligence from other sources. And knowledge base is more internal. A lot of cyber team, they use wiki, Confluence, or just a PDF of process definition. And for them, when they are in the middle of an incident, the last thing they want to do is to search documents, find the right article. So our mission was to surface the right article for them. So I try to tap into this example as we go and try to build the product virtually. But first, yeah, let's go through a bit more of the definition. What is AI? When to use it? And it was an interesting joke. The difference between machine learning and AI, if it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably AI. Unfortunately, today it's written on PowerPoint, so it's self-deprecating. But one interesting approach is to see that obviously data science is the technique behind it. But data science started more than 50 years ago. So data science is focused on the insights about people, sometimes about machine, fortunately, in cyber. But then machine learning uses those insights to predict directly for the user. And then artificial intelligence directly go an extra step through actions based on those predictions. But it's one point of view, not everybody agree with that. But one thing everybody agree with is that AI is the bigger concept and machine learning is a subset. The AI at the end of the day is about mimicking human intelligence, human reaction. So there's some rule-based algorithm which are not machine learning, but they are AI. And then within machine learning, there's deep learning, the more flagship domain, and using a neural network. It's a bit heavier in terms of data, training data set technique, but yeah, the accuracy is getting a lot higher. And we focus on machine learning today. So if you take only machine learning, there is already a lot of algorithm, and there's three main types. The most famous is supervised learning. When you provide a training data set to your model, it will learn from the data. So you need to tell the model what is good, what is not good. The classic is what is a cat, what is a dog for classification. Unsupervised learning, here you don't really need a training data set. You don't even need a label. It's up to the model to find patterns. And usually it's about clustering. What are the cluster in your data? Or dimensional reduction? What are the feature or columns that do not really contribute to any patterns, pretty much. And the last one, also maybe getting more traction, is a reinforcement learning. And this is, you don't really provide a data set as such. A typical example is game. So I think now for the last 10 years, computers have beaten the best champion in chess. And actually the way to do that is to let the computer play against himself and to give him one target. And his mission is to optimize his target, winning. So we learn, if I did that, I won. So you will learn by doing. So it's about, yeah, having a loss function to optimize. And at CyberAssist, we were focused on, first, we use dimensional reduction to remove some of the noise. Then we use clustering to identify, for case history, what are the main clusters. So we have to kind of research how many we want to classify, because then we move to classification. Once you know the 20 type of cases you want to flash out quickly, then you can move to classification with training data sets and so supervised learning. And actually, one of the interesting comparison is that classical programming, you give data and rules and you have an answer. When machine learning is about giving the data and the answers, the label, and the model will create the function, the relationship. So it's non-deterministic. Classical programming is deterministic. For an input, same output. For machine learning, it evolves. That's why there's a bit of there are some risk. As the system learn, the output for the same input will vary. So if we take actually machine learning, it's about having an input, then the model based on the historical data give you the output. Because there has been some cases where models learn the wrong way. It was the case for Microsoft with the Tay chatbot, and in 24 hours the chatbot became racist. He learned from the interaction with people giving some bad jokes. Or sometimes you have also adversary that purposely introduce some bad learning to introduce bias and disturb your model. And it's also a bit of the same story with Facebook and the American election. When people react to strongly, it learns that and we push more and more the Donald Trump ads because people have a stronger reaction. So yeah, you can have some bias to be aware of. So this is we don't want to use AI because it's non-deterministic, when it's really life or death issue. But let's have a look when to use AI together. So let's just bring a few categories and try to see together. For example, for financial services, what kind of use case maybe you've seen or interacted with?
You mean some use cases?
Yeah, some use case where AI is used. You read maybe before.
Oh, yeah.
I start with you, David. What would you say?
I reckon for finance, because I worked at the bank back in the days, I reckon like checking up fraud, that would be something that I think. Yeah.
There's a lot in finance. I think it's very rich. I just pick one here. I put
there you go.
fraud detection. It's pretty similar to the cybersecurity case, because it's about finding the anomalies really. So
there's a few in the chat actually, Sam. Maybe you can take a look at the chat. There's a few people.
Yeah, customer feedback, personalized experience. That's true. So personalized experience is key for all the SaaS experiences. Credit rating. Good. And about marketing, there was some of the where we can consider marketing to personalize experience. At the end of the day, now it's all about the user experience. It's part of marketing. The spend, yeah, it's true. I think that's the one I picked.
Spend.
As well. What did I pick? Ad targeting.
Ad targeting, also, spend, promotion.
Yeah, so it's quite linked. One popular domain is attribution. You need to find out of my spend, where did I achieve conversion? Is it through this type of ad or other channels? Very good. Customer support. Somebody mentioned already. Customer care. This one is a bit polemic. Chatbot. Who hates chatbots? Who love chatbots? Yeah, they have a bit of a bad reputation. Why don't you like them, Dave?
I just don't like them. Just takes too long. And maybe ask Clint. Clint doesn't like them too. Why do you hate them, Clint?
I always find like my request is, maybe it's in my mind, I feel like it's a lot more esoteric than what they planned for. It's just a really niche problem.
Yeah.
That's true. A lot of them are scripted. They don't even use a proper NLP engine. So that's why it's a bit bullish. They try to push you towards one channel, download this brochure, give me your email. So yeah, it's a bit pushy. Maybe we can transform, making them less pushy.
Yeah.
How about e-commerce? I think someone said personalization is a key one for e-commerce. Which one I put? Recommendation, yeah. And Amazon being top. We've been working on that for maybe 15 years to recommend the best product to upsell you. How about manufacturing? Very different domain. I don't know if you have anybody working in manufacturing or industry. Yes, predictive maintenance. Yeah, that's the one I picked as well. There's probably some other. I spoke to somebody who worked on automatic chip unloading. So you can pick up a container and with image recognition, it will find where to put the container by centimeter, maybe millimeter. So let's have a look. So you said anomaly detection. Let's have a look to the kind of the technique used behind those use cases. Similarly to detecting, I worked on detecting phishing emails, which is quite often, or some other cyber cases, it's about finding suspicious transaction. So anomaly detection is used also in cyber fraud. Ad targeting is classification. Usually it's about segmentation, finding among your cohort of user, what are the segments, which one you should push, which ad. Chatbot So it's NLP, natural language processing. Recommendation, we are recommender. Sometimes you also use classification to segment. And predictive maintenance is regression, which is more about continuous, predict one number as opposed to classes. But yeah, there's a lot of technique. So the main domain are computer vision, NLP, speech, so speech recognition, speech synthesis. OCR has been around for a long time, which is pretty much part of computer vision. It's about recognizing letters. And bottom right is what we're going to talk about, is about the case when you need to build your model. For the other cases, there's actually a lot of service provider that can provide image recognition, NLP. So I listed a few of the most famous. I would prefer to list less famous, but we have the most famous one, NLP. AWS of Comprehend, Google of Natural Language AI, Microsoft Cognitive Services, and IBM Watson NLU. They call it Natural Language Understanding. Image. So I worked a bit on recognition. I was using on a product that can recognize on an attachment whether there is confidential written on it, watermarking. So I did a bit of case on recognition, but those cases, they are very expensive. Basically, for a million, so there's a lot of attachment. If you treat a lot of emails, it stack up very quickly. I think it was about $1,000 for $1 million instances. But so my co-founder was very much Microsoft, so we use the Microsoft bot framework. Google acquired Dialogflow, and then speech for speech synthesis. And the interesting one is at the bottom is what is called, so this is called AI as a service, when you just tap to an existing model through APIs, send your image, and you return some tags, send your voice. When the bottom layer is ML as a service, machine learning as a service, which is pretty much an evolution of IDE, integrated development environment, when a lot of things are done for you. So for example, you can just load the data and it will randomize your data set. It will extract 10% for validation, 10% for testing, and you will run multiple models for you, compare them in terms of performance. We're going to check how to measure the performance after. So there's a few links. So let's build a product. Let's go through the cycle together.
Oh, hey Sam, if you don't mind, I might just jump in to ask a question, because I think Clint got a question in the chat.
Okay.
It's a little bit long. Hey Clint, do you want to jump in and just ask Sam?
Yeah, I guess. Yeah, I'm just interested to know, I think a common question that I hear and I still haven't figured out is, when you decide that you should be using those AI tools, whether it be NLP or whatnot, and I understand it's depending on the use case, depending on the technology, but is there a framework that you would advocate, based on accuracy or speed, to decide whether human process is better or AI tooling is better?
Yeah, that's true. It's a good question, tricky question. Actually, I think, yeah, it's all about customer value. Your goal is not to use AI, it's to provide value to your customer. And we'll talk about the UX, but sometimes you can just mimic, validate first if this AI will provide value. So you can create some prototypes or some rapid prototyping, and then it's more about working with the data scientist to find which model will bring value, because the data scientists, they are good at optimizing a model, but your goal is to really making sure you don't lose track of your customer proposition. So, but then whether you use image NLP, yeah, this is pretty much about the use case. Is it an image experience, a voice experience, or if it's more about predicting, then you have to use your own model. But I think I got a few references in the appendix that could give you more insights.
Awesome. That's a really good answer. Yeah, it comes back to the customer problem always. Yeah. Cool. That's all the questions actually, Sam. So
that's true. That's really nice. Good key points, because sometimes as product manager, we fall in love with the problem. Sorry, fall in love with our product. I think we should fall in love with the problem first, not really the shiny object phenomena. I want to use AI. And so it's even stronger for AI. Always focus on the customer problem and pain points, which is, I think, the top of this cycle. So you follow the same cycle. You still have to discover, user research, really have a crisp understanding of their pain points. So design thinking is great for that. You can do some interview, empathy mapping, test some mock-up, and then the area that is a bit more specific will be definitely development. So we will dive into the dev area, but you still need to use lean, do some cycle of build, test, learn, and then go to MVP and carry on actually learning with your MVP. But the rest is about the same. Product strategy, having the right business case, touch base at the end. The last slide is about some differences on business casing, but having a clear vision, a clear North Star metric, what you want to achieve, then find the best way to touch your customer. What's their water hole? I like this idea of water hole. Everybody, every community have a one point they converge the most, whether it's a blog or some news. So try to find the channel to touch them. Then growth, obviously. Maybe there's a bit more A/B testing that you can use. So you have A/B testing of the experience, but you also have A/B testing of the underlying model. So you can have a kind of double layer of A/B testing, and then operation. So there's also maybe a bit of some touch points on measuring your product, but also measuring your model. Sometimes we don't always go in par. So that would be maybe the operation piece. But yeah, we said, yeah, we still have to validate the problem, the MVP. And one interesting element kind of coming from kind of the job to be done. At the end of the day, your mission is to equip your user to do his job faster or more in a more enjoyable way sometimes. So pre-AI, as product manager, we always focus on the feature that will provide value, but the user needs to learn these features. So at the end of the day, features are friction, because to be able to be efficient, to get the job done, your user, to become a superhero, you need to become a super user. So you create some pain points for the user. And the idea of AI is to digest a lot of those features and do that for them. So the number of features they need to learn is a lot less. So for Cyber Assist, it was about surfacing the right document. It could have been just a search feature, but yeah, we go an extra step. You don't have to click on anything. Here it is in front of you. Same for Google autofill. You can autofill what you're searching, recommendation, medical diagnosis could be done manually. So you accelerate your job to be done. And yeah, one of the interesting, a bit more nitty-gritty aspects is about optimizing for one target. So if we take e-commerce as an example, if you optimize for one target, sometimes you don't have the outcome you need. So the bottom layer is about finding the right combination. So your mission as a product manager is to find the kind of the weighted average on to provide the right target. Because if you optimize your model for click-through rate, a lot of traffic, your model will push appealing product with a nice description. It's maybe not what you want in terms of a business strategy. If you optimize for the volume of conversion, purchase, you will maybe go for low value, you want a lot of transaction. Revenue, it will optimize for a high price, but low margin. So maybe not the good strategy. If you go for the profits, then it will really optimize for the boring items. So you see there's no single one target that works well. So you need to create the mix and find a weighted average. And one of the tips is quite interesting is to provide a feedback loop to be able to optimize that. And one thing that is done a lot is in-stream labeling. It means that when you use your user interaction as a new label. So if the user clicked on the recommendation, it's positive. If he didn't, it's a negative label. If he converted on a product, so then it becomes a new training data set labeled as good or no good outcome, but you can now use for the next training cycle. So you don't spend energy of labeling. Some companies, they even use Fiverr to get some data labeled. Is it a cat? Is it a dog? The best scenario is when you create a label through the user experience. And yeah, talking about the performance, it's maybe the most and the only technical diagram. It's about when you optimize a model. This is called the confusion matrix. So you got your prediction, the model, what you predict in the column, positive, negative, and what is really the truth. Was it positive or negative? So positive prediction for positive case is a true positive. And then if you are predicting negative, it's a false negative, because it was positive. And then true negative is actually you predict true, you predict it was wrong, and it was negative, and it was negative. That's very clear. So this is called the confusion matrix, and you can optimize either for recall. So recall is when you want to have you can accept false positive, but you don't want to see false negative. For example, for medical cases, it depends. If you're predicting whether this case has cancer or not cancer, it's better to have some false positive. Sometimes it says you have cancer, but you don't. At least you have some more doctors that will check that. Because if you miss that, the client might not start the treatment it needed. So we call it optimizing for recall. You don't want to see false negative. The opposite is to optimize for precision. Here you don't want to see false positive. So example is fraud detection. Fraud detection, so there are insurances behind our credit card, and it's better to not have false positive, because a false positive will block your card and will annoy user. When sometimes false negative is okay if you miss a few fraudulent transactions. The insurance.
Hey Sam, quick question. Like this one confused me a lot. That's why it's called the confusion matrix, right? So what can you give some examples of, like, what would be a false positive and a positive, true positive and a false positive? Like what would be a good example of those?
Yeah, even for those cases, for medical diagnosis, true positive, your model say this case has cancer, and then when you do further check, yes, we had cancer. So that's a true positive.
Oh, okay.
False negative, your model say this has cancer, and when you do the cross check, there was no cancer. That's a false negative. False positive.
Got it. Yeah, got it.
So for medical, you want to optimize for false negative. False positive are acceptable.
Got it.
So fraud is the opposite. So for fraud, if you take false negative for transaction, it means you predicted no, it's not fraudulent, but it was fraudulent. In this case, the insurance will cover the case. And false positive, you predicted it was a fraud, but it wasn't.
Got it.
Maybe I'll put there's some clear video on YouTube. I'll add the link for us. It will explain it even better. But yeah, so you have to make a choice. It's your mission as a product manager to find the right balance and optimize for one of them. So this is for supervised machine learning. Yeah? So let's talk about the team. There's a bit of a larger team when you have some machine learning involved. So there's a bit of 3 teams. I was surprised myself that data scientists, they work on building the model. They pretty much never deploy the model. There's a clear cut. So it's machine learning engineers deploy the model. And sometimes you have even the software or application engineer after that. So it's a lot of synchronization between first the data. Can I find the right data for my problem? Doing some cleansing, wrangling, ETL, export, transform, load. So actually there's a lot. This square is small, but it could be the biggest one. You spend a lot of time on the data. When data scientists are more independent, it's more about finding the right target, precision or recall. And then the deployment is about, pretty much creating the API endpoint for the input and output. And one thing that's quite interesting, actually for a bigger company, is to create a center of excellence. But instead of having, so you cannot really have a data scientist for every squad, and not every squad need data scientists. So it's better to have a center of excellence with the tooling, the capability, and also the sharing. So you can have 5 squad. They all need some capability. At least it's not siloed. We can learn from each other. And yeah, let's maybe I think the most interesting piece. So we saw the cycle for as a product manager. This is more the cycle for the dev cycle, and it's also linked to what is called the flywheel. That when you have a data-driven product, the more data you have, the better you can optimize your model. So the more accurate it is, the more value you provide to customer, and hopefully more customer will come generating more data. And in this, it's kind of similar. You still need to have a crisp understanding of your problem and find the right data. You still do prototyping of the model, prototyping of the whole application, MVP. Actually, at the end of the day, nowadays, prototyping and MVP are not necessarily separated. An MVP is an advanced prototype, but usually you start having some real user, real load, some more telemetry to measure and then improve your product. But the difference, the new thing is that within that circle, pretty much during the prototyping, there are sprints for the data scientists. So not everybody uses sprints, agile. Most teams use agile, and sometimes Kanban is very popular among data scientists. So they can have different model that they move to done. So yeah, the new thing is data preparation. You really need to find the right data for your problem, building the model, and having some different models. You can measure precision and recall. You can test. So one of the classic, you use 80% for training the data set, 10% for validation or fine tuning during the build phase, and then 10% of your data for the testing. And the rule is to have 1 divided by square n. If you have n samples, or if your universe n, you need to have a sample of 1 over square n. I put that in the appendix. One new thing is we do A/B testing on model to compare them, and there's also a technique called shadowing. It means you have you deploy for prototype 1 model. So 1 model is connected to the user interface, to the user experience. But there's a second model in the background doing exactly the same thing, exactly the same input, but it doesn't output to the user. You just log it, and then you can compare which of the model performs better. And then if we dive into this inner circle and provide a bit more description, as we say, it's all about data. And one of the challenge, data is all over the place. Huh? If you have e-commerce transaction, CRM profile, part of the engineering. We'll have also some statistics. So you have a lot of data with different formats. So normalization, ETL, export transform load is a big element. And if your mission is to not to be excited by the data, but really make sure you got the data that represents the problem you're trying to solve. And if possible, in the tip, I talk about federating. So federated learning is about what you learn from customer A, you can apply to customer B. So usually in retail, by default, customers are all in one same data set. But for B2B, so I'm more on the B2B SaaS domain, it's a lot more difficult. Usually, you cannot always use data from customer A and apply it to customer B. So there is a trend to put some, to anonymize, but you need to put that in the contract. Dave?
Oh.
I thought you had a question.
I do, yes, actually. Oh. So the question I have is actually, how have you come across any challenges finding the right data? Like, what's the biggest challenge of like connecting different data and different things like that at the workplace? Like, because yeah, how do you deal with that as a PM?
Yes, for Cyber Assist, there was a lot of source of cyber incidents, whether it's case management, ticketing, so the IT help desk. So we all have a different format. You have people having their own Excel spreadsheet of the cases they closed. And then in terms of articles, there's a lot of different formats. You have Confluence, Wiki. So you have a lot of different formats. So the goal, the main target is to make sure you got the feature, so the columns will contribute to your prediction. That's pretty much. And then if you have different data lake, you need to have one identifier that will link them. So if you have statistics about transaction on a customer, then you have
to link them.
Yeah, you need to be able to link them. Otherwise, there's no possible correlation.
Makes sense.
Then the build train model. Usually, data scientists are very much independent, but your mission is to make sure you use the right parameter, and then work with them on the testing to optimize precision versus recall. And then the deployment is about making sure you got the right APIs. I think it's a bit less. Some people I did a few interviews, and the people say deployment is a big piece. So it's taking a long time to take this model and then put it in production on different environment, different API. So not to be ignored. And if we dive even deeper on the parameter tuning in the middle, that's we call feature engineering. And that's one of your mission as a PM is to remove bias. So first, remove feature that will introduce bias to recognize gender or minority. Although it's always difficult. There was a case from Amazon when we did remove gender, but so it was based on CV. It was analyzing CV and providing a recommendation. They did remove the gender from the training data set, but depending on the way people write their CV, he was able to find another feature that correlate with the gender. So you did introduce bias towards men, obviously. And so it's not because you remove gender that you're safe. So you need to test, actually. You need to test your model, take some male, female, and then see whether the result is biased or not. But at the end of the day, because your training data set is a subset of reality, it will never represent the entire universe of cases. There is always a bias. So you need to be aware of this bias. And so that's the main goal. But just the last thing, sometimes surprisingly, it's the case for phishing. some feature you think are irrelevant, and actually sometimes they do contribute to the accuracy of the model. So for example, for phishing, which is usually about a dodgy link within your email, there's some other metadata entry, like whether it's using DKIM as its domain validation, was a big predictor. So yeah, don't ignore features that you think will not contribute. Just work with data scientists, because it's a long endeavor. So my recommendation is don't start an ML project. Well, this is my ML project. Let's see, it's more about iterating again. So it's more about keeping on testing hypothesis. Can I provide value with this prediction? Can I provide value? So for CyberAssist, it was, can I provide value with surfacing similar cases? Can I provide value by surfacing an article? And sometimes you can learn by different experiments. Yeah, the funnel is very long. Sometimes out of 100 ideas, there's only one that really makes sense, provide value, and is financially viable. And because one interesting thing is the diminishing rate of return. We always want as much data as possible, but your accuracy, your model will stagnate after a while. It's not because you provide you double the number of training data sets. The gain will be very marginal. So you need to find out as a product manager. Data scientists are very idealistic. We want the best, so we want to carry on as much as possible. So it's your mission to make sure you get you don't explode your R&D costs and stop when you get the right accuracy that provide value to your customer. So for us at CyberAssist, we stopped at when we had identified 100 clusters of case history. So this is the modeling, the new piece. Now what? So we're still in the cycle of a product manager. UX is key. So you still have this tribe of designer, PM, and engineer, and now a data scientist, either within the tribe or outside. So design is key, and it's very key to be transparent. I don't know, this is the Facebook ad. Why am I seeing this? I don't know if you guys are now annoyed when something is pushed to you. At least the idea is to recommend, to explain why Café de France is recommended to me. That's suspicious. 99% match, and it's good. You need to explain why your users see that. And Netflix changed actually the UX. Now you can always see because you watch that, because you like this movie, this song. So always explain. There's also another domain of UX linked to AI is voice UX. So this is visual, but voice UX is an even bigger challenge. I recommend I join the Alexa Skill Builder program. It's free, and you get to create. You know, on Alexa you can create a skill. I created a skill on what's the best sport for today, according to the wave, the weather, the wind, and it's very so. The challenge on the voice UX is about happy path versus exception. You always have the happy path in mind. The customer will ask this, I will answer that, but nothing goes according to plan in many cases. And so you don't want your user to spend their time on exception treatment. So all about the UX and all about the explainability and transparency. So you want to show in your UX what you're doing. You want to make sure your model is not biased, explain that you're using the data for prediction, and be fair across population. And it's a great Netflix movie. I don't know if you've seen Coded Bias. And this MIT student and then researcher, she surfaced that both Amazon and Google had a bias on their facial recognition. So it works very well when you're a 40 years old white male, not as well when you're a minority. So yeah, a very great documentary. To finish with, I think, but 2 or 3 slides. As we say, we still need to validate hypothesis. So don't jump into modeling straight away. First, you can use concierge MVP. So because the closest proxy to AI is human intelligence. Soon we're going to be a subset of AI. Is human interaction. But yeah, you can use, so for example, for Cyber Assist, I was behind Slack. I pretended to be a chatbot, and cyber analysts sent me some question or some indicator of compromise, and then I was searching in the case history, searching in the documentation, and give the answer to them. So the idea was to validate what will bring value to the customer. And actually, we found out that the articles bring a lot more value, save more time, and time is money. But not all AI product can be simulated as a Wizard of Oz.
Oh, hey Sam, just while you're here, so actually we got a question in the chat around, yeah, how do you test out the value of AI before you built it? Because you mentioned it's very heavy involvement, like you got to get a data scientist, get to collect the data. Yeah, I got a question in the chat around like, what are some ways to validate the value without investing too heavily into it? And I think this is one of them, the MVP, but any other ideas that you can think of?
Actually, it's the same lean startup approach to build, test, learn. So find, so you know a product or you know proposition, and find the hypothesis you want to test. Is it this experience that will help the user? Is it another experience? So I think so, but hypothesis testing, and then it's a good segue to the cost element, because you mentioned the cost. So the value is pretty much the value proposition. And then, stop moving. And then the cost, it differs a lot whether you build your model in-house. Is the bottom, I use a bit of a quadrant. I don't know if you read easily, or if you use AI as a service, if you use services from the cloud vendor, mainly on image analysis, NLP. So if you use the cloud services directly, you pay for each request. So then it's a big operational cost. Each image you submit, you have to pay a few cents. So you stack up a lot, and it hits your margin. Not very good for your gross margin. If you build the model, you'll have hopefully a lower operational cost, although there's still operational cost, but you don't have to pay for every single image. But you have a lot more upfront fixed cost. Obviously, the R&D team is a bit bigger. You have a data scientist. We have some tools we use. You need to purchase the data. Now there's also a bit of a market for purchasing data, and the infrastructure, monitoring and telemetry. Maybe more on the blue side actually. You need to build the telemetry for your model. A bit less if you use AI as a service, but you need to keep an eye on the efficiency of the services you use. And if you pay cents per image, and it's not working in the way you want, you need to measure that. So yeah, measuring the value created is always the best. You don't want to measure only precision versus recall. At the end of the day, it doesn't matter if it doesn't provide value to the customer. So the telemetry is both model and product value proposition. Wow, there's a storm here in Sydney. And so yeah, I think the guideline is to iterate with data scientists to flash out whether it's going to be a complex endeavor, a lot of data, missing data, and then you can do a bit of a early ROI. Should I go in-house, or is there some option? Maybe to start. I think the good thing about AI as a service, and finish on that, is to use them for prototyping. Rekognition by AWS It's free to use. You can test it with 100 images. It will cost peanuts. So it's a great way to do rapid prototyping. Test if I recognize the images. Maybe it's used for when you post images when you want to on Gumtree. Recently, I had to post. So you will recognize the image and classify automatically for you. So maybe you can do a prototype using AWS recognition as opposed to boiling the ocean. That was the last slide. Then I got some references. I will add some more for you guys.
Cool. So just to wrap up on that question, Sam, so we're saying that we should actually understand the value first, right, of the problem that we're solving, and then figure out using some sort of like AI as a service to do some quick prototype so we can understand the cost, and then we can work out the value of whether if it's worth investing our time into this problem or not.
Yeah, exactly. Always iterate on your customer proposition before iterating on any model.
Spot on. Yeah, good. Yeah, makes sense. Makes perfect sense. Just like any technology that you dive into. Yeah. Yeah.
We're still agile product development.
Yeah, good stuff.
And maybe if there are some experiences to share, it's always good to hear from you guys if you use any AI technique.
I think for the last 5 minutes, are you okay to take in a few more questions, if that's okay?
Yes. Yeah.
Awesome. We got another question from Shankar. He says, what is the role of a product manager in data preparation and model selections? In the chat, it says, for example, can a product manager stop with problem or need definition, outcome assessment, cost harm consideration, and leave the algorithm selection to the data scientist? So where's the boundary here from a product manager versus data scientist?
Yeah. At the end of the day, it depends on the company. Large company, probably you're a bit less hands-on. You rely on the data scientist team, but the starting point is always very important. The data. Sometimes data scientists they want to have a very efficient model, so they will use a lot of data, and you can lose track of what's the problem to solve. So really making sure your data represents your problem, which means if you want to provide recommendation, making sure this is the data for that lead to your outcome. So if you want to sell more of a specific product, although this one will be a bit biased, you don't want to do that.
Yeah,
but
true.
Yeah, at the end of the day, making sure the data will have what is needed for your outcome. So spend some time with the team to find the right data. Also, always make sure there's a link, as we said. Your customer in the logs, you need to find him in the CRM, you need to find him in the server. So this one is a key element.
So I think it depends on the size of the business that you're in, right? So if you're like a startup, then as a PM, you have to do a lot of data preparation work, and maybe even recommend a model to start with. And if you work in a bigger company, then you might do less of the data prep work, because that's what a data scientist can help with, and then they can build a model as well. Does that sound a good? Is that a good summary?
There was a second side of the question, which is selecting the model.
Yeah.
At the end of the day, it's better to let the data scientist own the model selection, because they love it as well. And for you, it's more about understanding, are you targeting a specific prediction, so regression? Are you targeting a classification? Or is it more about finding pattern in data? So you need to understand the type of model, and have some interesting discussion with your data scientists.
And another common thing I see in a lot of workplace is that there's ambition for AI, but there's not enough data to build anything at this point. Yeah, what are your perspectives on how do you, if they want to do it, but how do they get ready to do it?
Yeah, that's true. So it's good to start with your data, although in many cases, when you start, you don't even have the agreement from the customer. If you didn't include that in your original T&Cs, there's some things you're not supposed to do. But yeah, starting with your data, making sure you got the agreement to use it. And then there is also a market for data. Through AWS, they have a big marketplace. Some are free, some are not free. Through the Australian government also introduced, I think it's called Script PM. There's a kind of an open platform when you can access statistics from the government. And the last piece is partnership. There's many cases you use third party in your product, or you collaborate to create a user experience. So now your partnership, you want to start talking about partnering on the data generation, data accumulation.
So like working with companies like Quantium or something, you can get the data from them. That's
true. Actually, these guys,
if you have the money,
you can do the whole thing for you. They do a lot of modeling with your data. They can add their own data, which is also actually one of the elements of AI as a service. Some are defined model. You don't provide the training data set. Some you can actually complement the model with your own training data set. For example, for bot, the dictionary of a bot is very different if it's customer care. Actually, customer care is also a lot of product name that the basic dictionary would not know. So you need to feed some new dictionary of your products and other terms specific to your company. And then, the scenario is always different if it's customer care or if it's a cyber analyst. That would not be the same dictionary. So you can complement the model, kind of nearly shift a bit the model towards the domain.
Got it. Cool. I might open up the floor for some question to Sam, because I think I've asked enough. Has anyone got any questions? Feel free to unmute yourself or ask in the chat. No questions? Cool. All right. Well, there's nothing more. Hey, Sam, is there anything that you should recommend us follow up on? Like any books we should read? Any, any documentaries we should be watching? What are your recommendations for further reading?
Yeah, Coded Bias was interesting. It doesn't dive into the technique. No, I think there's a few online courses. I did one by the MIT. There's also one on Udemy, one on Udacity, I think is a good one. So I'll put it in the links. And then YouTube, actually your competitor, Product School, Silicon Valley. I've also an interesting talk. I put it there from one of the Microsoft product manager.
This one, okay. Cool. All right, so if there's no more questions, I'll wrap it up so we can get back on our day. So thank you so much, Sam, for sharing your knowledge with the community. This has been such a in-depth learning for us, and I'm sure a lot of us have taken a lot of knowledge from you. So thank you so much for coming. And and also don't forget to pass your contact details as well on the last slide. So if anyone got any questions, connect with Sam, reach out to Sam. There is so much we haven't learned from him around this topic, so feel free to reach out to him.
I'll put it in the chat. But yeah, feel free to reach out. It's been a pleasure. Thanks a lot, Dave. And it's great to I like the idea to have a community and we can share, learn from each other, so that Australia will become the best PM practice in the world. Is it your mission?
Yes, and help people find fulfilling jobs in the product industry. And I'll share your LinkedIn to the chat as well. So if anyone want to add Sam to LinkedIn, feel free.
Beautiful. Thank you very much.
Cool. All right, so thanks, guys. I'll see you all in next week's class.